about the future of Wireshark, but more specifically about the future of capture analysis, about our whole field as per se. You're going to hear controversial points, you're going to hear vendor-centric points, but that's exactly what we're here for. So we want to give you a full field how different areas or different companies portray this kind of field we're all in. Sounds great? Yeah? So let's get right into it. We have Chris Greer. He doesn't need any introduction, I think. He's the packet head, and, if you really need to know who Chris Greer is, you were sleeping in his class. You know who you are. We have Ron Groulx from LiveAction. LiveAction, one of our main sponsors. Hopefully you all talked to him at some point during the conference. Same goes for Steven. Steven is a long-time contributor to the SharkFest team, organization, whatsoever, and also the CTO of Endace. If he looks tired, that's because he's from New Zealand. You see, that's how important you are to him. He always hops on a 20-hour flight just to talk to you. We have Nigel from Sysdig. I'm kind of under the impression to send the intern, but no, he knows his stuff. So listen when he talks. And we have our homegrown John from Profitap, ending up the US market. Actually, you're one of... No, you are from the US as well, right? Yes. Ireland, you see? We have an international panel. Canada. So, Chris, you want to bring up your Nicaragua residence? Or... Yeah, not there anymore. Your country of Florida. Don't see anything. No. As a European, it's we're allowed to just. So let's start with our discussion. I'm going to start with you, Chris. Packet analysis. Is there anything going on that people are scared about doing in the future, or afraid no longer be able to do it?
Oh, for sure. I think a question I get quite a bit is just now that so many protocols are encrypted, or proprietary, is there any real value of doing packet capture, and just how much can we get out of it? I don't know if that's something that any of you have experienced, but just there's a perception that since there's so little that you can grab, that the packet is getting further and further difficult to read and behind the green lock.
John, how would you tackle the encrypted packets and capture in the future?
Yeah, I agree. Is this working?
Yeah.
Encryption, when they started encrypting packets, it became kind of an issue for how much you could get out of the payload. But a lot of times you're trying to analyze the frame or headers or certain things about the traffic connectivity issues. And we're doing things like adding Berkeley packet filters to some of our equipment so you can do some other things with the packets that might help. Encryption is there for a good reason, but it doesn't mean that we can't solve problems with packets.
Well, coming from the land of really strict data protection laws, I would argue that I don't want you guys to read the encryption ever, and I don't want you guys to be able to see traffic at all together. How does this affect companies like LiveAction, for instance?
Yeah, so we always have this stumbling block as we evolve with networks, right? At the beginning, when we were capturing packets, it was on a hub. It's easy to plug in, and we can see everything. Then we evolved into switches. And how are we going to capture packets now? We can't just plug into the switch, and it's localized to a collision domain, so we can only see packets there. There's always this stumbling block. We need to evolve our technique in how do we get the packets, right? As networks evolve and add complexity of how to do that. So we're really just evolving our technique on how to capture these packets, right? So as we introduce security, this is another means of abstracting our means to capture and get the data. We need to look at new techniques. And one of the things, instead of just plugging into a span port to get the packets, for example, we now have to utilize things like distributed agents and collect those into a centralized, we call it packet broker, And that's where we can start to look at the packets before they get encrypted, before the encryption happens. So there's some new techniques out there that we're kind of evolving into to allow us to do the same troubleshooting, the same steps that we normally would do.
Now, it's interesting that you mentioned new techniques, because I'm thinking getting information out of a system and getting information out of certain areas where they don't want to bring you that information actually is a rather old field, wouldn't you say? When you go into session analysis and go to sysinternals and stuff like that, it's actually you're doing the same thing, but with stuff that's been around for years, right? Yeah, that's for you. That's why I'm looking at you.
Absolutely. So, then that's a really interesting point. And as well as more and more stacks are becoming more complex, I think the best example I can provide is the cloud. Maybe it's just me.
John, could you? I think it's closer.
I think that should be fine.
Yeah.
So, I think the best example I can provide is from the cloud. So,
hello.
Oh goodness, sorry about that.
Screen.
So, the cloud is the best example I can think of. So, as things become more and more complex, I mean, at the end of the day, we're still talking about endpoints, devices. We're still got network traffic. The thing is, to manage it on scale, to make sense of what we're working with, there's more and more layers of abstraction. And because of that, at one point when everything was, say, monolithic applications, we had network routers, switches, firewalls, that kind of stuff, we could say, I'm going to monitor everything from this IP to this IP. And it was really manageable and really approachable. And we knew what we were doing with packet capture analysis. And then with the cloud, we'd stop talking about IPs. They exist. I mean, they don't go away. That's always going to be there. Packets are still there. But we talk on these level of abstractions. So if I'm monitoring these IP to IP, well, what are they? And I think that is probably the most interesting place we're coming to. The providers of these infrastructure, they say, well, we have logs, and then you can monitor system calls if it's a device. And that's all great. But where does that tie to packets? And I think that's a really interesting bridge we need to cross. And I think it was really interesting yesterday in the keynote from Gerald in the morning was just about that, using techniques, tools that we're familiar with, and just bridging that gap into the world of logs.
Now, when you mentioned logs and mentioned cloud, there is a lot of data going there. And if you say you cannot decrypt anymore, you have to read more or less the meta information. Stephen, at some point, would you say that the information you see actually is becoming that the filtering is the more important part than understanding where the data is coming from?
Filtering to
being able to find out where in the data is your information.
Sure, that's a good point. And, it's interesting that one of the comments again yesterday was how you capture is almost as important as what you're capturing. So you need to understand how to go about capturing packets and also where. So where within a network you're capturing the information really matters, and then collecting the metadata about that. So collecting the information, not just about here are a set of packets that I captured, but you really need to understand where within the network that is, because it makes a difference. Are you near the server or are you near the client? Are you on the inside or the outside of a NAT or a TLS proxy? So absolutely correlation of all that information, and then how you then blend that in with information you're getting from logs and things, and understand how those events relate is very important.
Now, John, judging from your experience, how easy is it when somebody comes to you and says, oh, I want to capture X, I have an application that's not working, or we want to monitor that part of the system. How easy is it to portray that this is one of the most important parts? Where to attack? Where is your center point where you attach? Is it something that's becoming easier, or is it still the challenge?
No, well, it's always a challenge, right? But we have what's called the application dashboard, and it does layer 7 fingerprinting, and we can fingerprint about 3,000 applications. And with that, you can look at it and kind of drill down into an application and go from there, like layer 2, layer 3, layer 4, or the reverse. If you know the IP and you know the port that the application is not identified, you can kind of assign that application to that IP and port. assuming the application is using that specific port or range of ports, you have to kind of take it one at a time. We've added a Modbus dashboard, which is for the industrial environment, and it's, UDP traffic. So it's a little hard to identify. And we've broken that out on purpose so that the industrial world can analyze that traffic a little easier. And a VoIP dashboard to do the same thing. So I don't know if that's going to get harder with all the encryption that they're doing or not, but I leave that to some of our smarter R&D engineers to figure out.
Always the engineers have to come up. But John raised an interesting point. The tools have to become more intelligent. The tools have to become more unknowing. Isn't it? I mean, it's kind of, in the AI world, you have this concept that as the models become more and more intelligent, they will do more and more stuff. So now somebody else can no longer be able to monitor that stuff because they lack the knowledge. Is it not a problem when the tools become all-knowing and the knowledge, the base knowledge goes away? How can you mitigate that?
Well, I don't think we're trying to mitigate it. More or less, we're trying to add techniques like AI to enrich the experience for folks that don't know how to look for things. They don't know the methodology. They can utilize new software to help assist, basically. We all use things like chatbots now, right? That's going to become a lot more common to do that. But I think from a data enrichment standpoint, that's the real challenge, is where do we drop and inspect? And we really need to figure out what data we can gather from all parts of the network. I agree. Metadata sources in the past were not telling us enough information. That's why we go to packet capture to figure it out. It's the data. It's very granular data. It's just a challenge on where do you position it, because we're locked out by security. It's getting in the way. So we just need to be a little bit more intelligent to figure out where the challenge is. Where do we put these analyzers to get that granular data? And so we need to teach the next generation what's the best trick to do to insert the packet analyzer so that we can get that granular data and make it easy to sort of drop and inspect. Because it is challenging right now. The cloud makes it a lot more challenging with just the abstraction of the network and security all coming at us at once. It makes it challenging to know, even for an experienced network engineer, where do I put this thing? How do I get all the data? Am I going to see everything that's coming into the packet analyzer? So we need to evolve our techniques on how to do that.
Nigel, what would you say is a good level of attack when you start out as a new employee in a job with either packet analysis or system analysis? How would you say is a good angle of attack to figure out what educational path you need to mitigate for those new challenges that present yourself?
Yeah, it's a tough one, right? Because when you talk to the cloud providers, when you talk to the companies that build these tools, they very much just focus on the abstractions. They talk around limited privileges and they talk about trust systems, and they don't really talk about deep forensics. They just say define guardrails and hope that things work. But in the time of troubleshooting, these solutions are great. So, I don't see packet analysis going away or anything like that. But I think the approach at which we use packets for analysis, or we create these captures, has to be linked to something tangible. And when we talked about those abstractions, it doesn't have to be cloud, right? There's all these different environments that we run applications or infrastructure that come around all the time. And if we can link to those abstractions, whatever way we're doing it, based on logs or some other source of detecting a behavior, something that we know is anomalous, unwanted, and we know it's network behavior, an outbound connection or something that we detect in a system call, then can we run a capture based on that behavior? Because at least then we have the abstractions that tell us that application, that device, that workload, even if virtual and it's ephemeral and it won't last very long, it'll be gone in 10 minutes. We know when we get the capture that it's linked back to those abstractions. At least we have something tangible to do investigation based on. We can't just, unfortunately, run big captures now and read the files and say, I know what's going on, because I have no context, because packets doesn't tell me virtual context, unfortunately.
Now, when you when you put that into amount of data, Stephen, one of the biggest challenges nowadays is ever evolving infrastructure, right? So 10 years ago, we were talking about 1 gig, 2.5 gig. Now we're talking about 40 gig, 100 gig links, and whatever they dream up next. The thing is it really practical to still have tools that do packet analysis at that point? Because 1 second in 100 gig, that takes you a while to sift through.
Yeah, it does. So it's true that, networks continue to scale. Network traffic is maybe scaling faster than our storages and our computers. So, as a vendor, it's obviously difficult to build things which will continue to work at those scales. I think a lot of it is about finding the needle in the haystack, right? So it's about, there's this huge flood of data coming in. We've gone from 1 gig to 10 gig to 40 to 100 and so on. 800 is coming. And so the ability to index all of that data as it comes in requires a lot of compute, a lot of specialized processing. Being able to index it and being able to search it so that later on you can come back and actually look through that data and find the things that are interesting is very difficult.
One of the things, Chris, that is currently, especially when you're talking now, you have 4 different vendors with actually quite a big variety of tools on stage. When you're talking about training, how can you, when you talk about packet analysis, it's easy, yeah? You use Wireshark, that's packet analysis. It's synonymous for that. But how can you train different companies? Do you have to be only tool specific, or how can you make a more generic approach into training to allow to grow this kind of understanding of analysis?
Well, I think that's where Wireshark has such a strong presence still, because I've always felt that the better you understand the packet, and Wireshark is the best tool in the world to help us to do that, it'll make analysis of everything else easier. You'll understand all of the products the better you understand the data source, which is the packet. So I think that still has a very strong presence. Like, we're not going to take a copy of Wireshark and pop it on a laptop and put it on a 100 gig feed and just hope for the best. We can't do that. But what we can do is take smaller data sets, understand how they work. I call it understanding the needle, because you can't find a needle in the haystack if you don't know what the needle looks like. So to better understand that needle, and also to better understand that these tools, these systems can help us to capture the needle. Because if I'm just doing that with Wireshark, I can get a lot of hay but never find the needle. So those two things can happen when we're in a smaller scale with Wireshark, and then that just feeds into, you better understand why you need a tool set like these guys provide. We've been approached by very large organizations, financial institutions mostly, and that's the biggest challenge, right? They're getting gigantic networks, they're moving to the cloud, offloading very large data sets, right? Hundreds of gigs worth of data, and these packet analyzers that we've had traditionally where we could just plug in and see everything on those pipes are slowly becoming ineffective at doing this, just the pipe volume. And so it's becoming really more of a sense of, where do we strategically position to find that needle, as Chris said. But first and foremost, we should understand where that needle might be. And by leveraging some other technologies to assist us, metadata on the network coming from telemetry built into the infrastructure itself, we can kind of get a sense of where we might bring that packet analyzer to inspect to find that needle. Versus just, we have this big, ginormous packet analyzer and it's plugged into the port, and we see absolutely everything. I think gone are the days that we can use that approach just by the complexity, the security, and the proliferation of data volume. So we have to be more strategic.
You have to be more strategic. John, will it ever come to a point, in your opinion, that we no longer need to actually examine the needle, but the tools that help us sift through the haystack are enough for the analysis?
So a couple of points about that. We have what's called a virtual tap. So it's a tap that you can put in your VM environment and tap your traffic right out of a chassis to a virtual packet broker, and that lets you identify, maybe through filtering the packet broker, what traffic you actually want to analyze on the cloud side. On the other side, you can also use pre-capture filtering to only capture the interesting traffic. That's quite helpful when you have a ton of traffic you're trying to get through. Same concept Wireshark uses for pre-capture filtering, but on an appliance level. What was the question again?
If ever these analysis tools will become so powerful that you don't need to go into the deep end of the pool anymore.
Well, we're looking into the possibility of implementing some triggers so that we can trigger alerts on certain types of traffic and stuff. But there's IDSs that already do that kind of stuff for people. We're trying to balance what we do with we don't think anything is really going to replace Wireshark, right? It's a fantastic tool. It's been there forever. These tools are to complement your toolkit and help you find, like they said, the needle in the haystack, which is really the art of analysis, no matter how big the capture is. Finding the specific problem is the number one rule in capture is location, location, location. Where do you put your equipment? You want to be as close to where the problem is happening as possible to start capturing, and then about from there, to find the issue or have capture capability on both sides, which is always the best, right? You can't always do that, but that'd be nice.
Stephen, I'm giving you now a really bad question, because coming from industrial automation, one of the biggest challenges in that field is cross-vendor cooperation, right? Cross-vendor collaboration, we do have a common denominator in our field, that's PCAP-NG. The data format in which we store information, that's pretty much the only cross-denominator that we have. But now we have a few people here working in IT, one or two, and John already mentioned IDSs. We have security scanners, we have virus scanners, we have all kinds of tools in your data cabinet. And for each tool, we have now individual management system, individual components. Do you see a way, or do you think that there can be a way to create a unified view for what network is across vendors to a point where there is a similar format, a similar idea about PCAP-NG for meta information, for metadata?
That's an interesting one.
It's a really...
Yeah, no, that's an interesting one. So, even PCAP-NG is a great format for storing packets and the metadata related to them. But really, the common denominator is still PCAP, right? So if I want to give a packet trace to somebody else and guarantee that they're going to be able to use it, I'm going to give it to them in PCAP rather than PCAP-NG, just because Wireshark will deal with PCAP-NG really well, but not all tools do. So you kind of still have to come back to a really low base. There have been some interesting attempts to come up with metadata formats for network-related things that can be shared between more different types of tools as well. There's community ID, for example, which is a common way of describing a flow. So if you have a TCP flow or a UDP flow, you can generate a community ID. It's a long string that's like a hash, and that can be used by different tools to communicate about the same flow. And I think that kind of thing is interesting. JA3, JA4 is another kind of attempt at coming up with a common language that tools can use to communicate and correlate between different things. And I think there are some interesting things people are doing in JSON as well, in terms of coming up with common eventing and alerting kind of formats that can be interchanged and shared, threat feed information, that kind of stuff.
Nigel, going from the network side of things towards the system side of things, one of the questions that was raised, and this goes into the same direction, one of the questions that was raised is, hey, you have this whole cool system test tool, blah, 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 but I want to see both worlds. I want to see both worlds in one place. Do you see this happening, or do you see that there's a common format, PCAP format, whatever, that you see the process information and the system information?
Yeah, I mean, we had a tool. It's used. I mean, it's part of our enterprise technology. It's called Sysdig, but not to be confused with Sysdig. Sysdig Inspect. And this comes out in this kind of SCAP format files. But it does kind of, see, the point is it was built with the concept around containers, ephemerality, and cloud native. So the idea here is we just needed some other additional context that wasn't necessarily in PCAP files. So I know it's kind of novel in its use case, but at the same time, it is bridging that gap. But again, there's going to be different demands for different types of tools. And we see that with LogRay. It's yet another open source project that people can get involved in. And it's the idea of like correlating, log activity with, potentially system call activity as well. So you have that kind of bridge gap.
Staying with you, somebody jumping into the field of network analysis, system analysis, and he found it cool because, you can play with cool, nice toys. What should they learn so that they can achieve more or the most in their jobs in 5 years from now?
Yeah, it's a really good question. So it depends on the technology you want to get involved in. But what I will say is nearly everything you can kind of do for free today. I think there's a misconception there that like everything's going to cost a lot of money. A big example is, if you go to AWS or Google Cloud, or actually there's even better clouds, smaller ones, that they'll give you either 30 days free trial, or they'll give you a tier that's specifically up to specific limits on the EC2 instances you create or equivalent VMs. And now you have small infrastructure, and this small infrastructure, you can run the open source tools, which are free. You can create the virtual infrastructure, whether it be, something like a Kubernetes or whatever it is, for dabbling in this virtual infrastructure. And again, at no cost, you're able to, I know it's not full-scale infrastructure that you're recreating. For sure, you're not going to get the same control and access, but you can create your IAM controls, the access controls in the cloud. You can create the virtual firewall controls, network policy, whatever it is. And these things, these primitives, these abstractions that are going to be used by people across the industry, you're using at no cost, but you are getting the experience, that hands-on configuration and misconfiguration. I need to fix that. I need to apply it. Maybe I need to create a pipeline. If someone is moving in that direction from, physical network towards ephemerality and virtual infrastructure, the cloud, there's so many free tools out there. And even better, there's free trainings, which is just, that's what I would say someone, if that is their 5-year journey.
Chris?
Yeah, I'd agree with that. It's been amazing to see how much free information there is out there, and especially over the last 5 years. Especially, I would say, in the cybersecurity side, there's a lot of tools that are great that you can just get your hands on. Try Hack Me, Hack the Box, those. And they also have some great Wireshark content because, again, a lot of those tools are fed from the packet. So,
Chris YouTube channel.
Or YouTube, yeah. But yeah, I'd agree with that. I mean, it's a good time to be hungry, have a thirst for knowledge in the packet space, because there's just a lot of great stuff.
Thank you. I want to thank you guys for doing this morning. A round of applause. We have, I think, about 5 to 10 minutes. Yeah. I want to give it up to the crowd. Has anybody got a question for our panelists that he would like to see discussed? Yeah, Josh?
Of course, yeah. One of the new techniques that a bunch of larger companies are using is called distributed tracing. So they're collecting logs from applications, they're writing distributed agents that are grabbing stuff, and they are presenting that in a unified interface that traces flows across different systems. Is there any future in where we should integrate packet level information, segment size distribution for a TCP flow, zero windows or low receive windows that pop up for a TCP flow? Is there any opportunity to integrate that with that distributed tracing group?
Yeah, Josh, I think that is the future. Eventually, we're going to get there in full swing. I think we're at the beginnings of that at this stage, right? So we see that in some products already, right? They have a packet capture component, some telemetry that they're collecting logs, net flow, the SNMP, multiple forms of telemetry, and they're kind of trying to stitch that together with that vendor's software, right? So it's not necessarily that all of the data is coming together, coagulating in one central source of truth that we can look into, although vendors love to claim that, right? They're the single pane of glass. But it's still a challenge, I think, at this stage in terms of trying to make that standardized, right? A standardized single source of data. But I think the future is going to be very interesting, where we can take these multiple forms of telemetry and start to bring them together to, maybe integrate AI into the means of utilizing the tool, utilizing how we interface with the tool. So
I don't know if I can talk to
Yeah.
that. So we have a product called IOTA CM. So our edge IOTAs you could put out in locations where you want to do your captures. The IOTA CM is a single pane of glass that talks to those other devices. You can aggregate and do analysis from one single pane of glass to our devices. It won't take metadata from other systems. It doesn't use, IPFix or JFlows from other systems. It's all internal. That's what we have right now for that.
Yeah, it's a good question. I think open APIs are really important. So that ability to have, we were talking earlier about common logging formats, making data interchange more free, allowing central tools like you might be using something like Splunk or Elastic or something like that as a collector, and the ability to then pull in data sources from different vendors, different types of devices, logs versus packets versus flows, and all of those kinds of things. I think that is probably where we're going, and then maybe AI will help then try and correlate these different types of data together. Sure.
IPv6 adoption is still slow, but making sure it's still on everybody else's roadmap. We haven't really done it well, but we have, with the equipment that we have, or of our own or can afford, development in a new fleet. I'm hoping there's commitment amongst tool vendors to continue development for P6.
I think IPv6 is in more places than you think. It's one of those things where people are quoting that 40% or 60% of internet traffic is V6, and it's because of mobile phones, right? So much of the mobile network is V6 based, is more of it around than you might think. And most desktop machines have been dual stack for years. So there is a lot. I think from the vendor side, I think IPv6 is pretty well covered now. I think most tools will treat V6 as the same level of citizen as IPv4. So if you are seeing problems with V6 support from vendors, you should definitely be talking to them about it.
We just completed IPv6 completely in our product this year. So it is, for some vendors, time to do it, I think. Finally, we've all been sort of hesitating it because of the adoption rate primarily. Some industries care about it more than others. There's still some sectors in specific markets that don't necessarily care about it too much. They have it, they should care, I think. And so tool vendors, if they haven't already done it, should be doing it now. So demand it.
There was a question back there.
Yeah, it's an interesting one. Like, what I kind of a little bit baffled with the cloud is like that they all have different approaches. You would imagine that it was a standardized approach and that all vendors would provide more or less the same service. And you see Microsoft will say, look, this is our network design. And then Amazon will come out and they say, yeah, this is our network design. And I agree that they are different and they're not standardized, which is a bit strange. And it's more obvious when we're talking about, it's services slapped on top of services, right? So we have like Kubernetes, right? And its only purpose is to orchestrate workloads. But as part of it, it has its CNI, a container networking interface. And these providers, whoever provide the CNI, they have to tap into the network of the cloud provider. And it baffles me that if you looked at the original, you had these, what they call VPC CNIs. It was like AWS VPC CNI, Microsoft VPC, and they all had limited or different scope and capabilities. I think that's being addressed somewhat by open source in a way, because these CNI providers, at least in the scope of Kubernetes, they're saying, okay, we've built our CNI in a way that it can work better with all of the existing infrastructure out there and better interact with it. But we're only talking about that specific service and its CNI implementation. There's just going to be standard network interface or whatever that you're setting up in the cloud provider. And yeah, there's no standardized approach. And I don't think they're even going towards standardization. So there are organizations that are locked in with a specific cloud provider, and that's all they know, and there's no issue there. I think where the issue exists is when you have a multi-cloud strategy. And that's more obvious in the likes of fintech organizations that have like failover between multiple clouds. And yeah, that is actually a complex solution.
Once again, open source to the rescue. But
Oh, sorry.
no, if somebody still wants to add something to that, feel free.
Yeah, no, but I think in a lot of ways, yeah, open source does solve it. Like when I'm talking about these services, again, I mentioned Kubernetes as this orchestration, but if you think about it, if you have an application on scale in the cloud, you're kind of talking about Kubernetes. The cloud provider is just the thing that provides the infrastructure. And what I find fascinating is the project of Kubernetes is open source. You know, each cloud provider provides managed implementations, or you can do it from scratch, but that's all open source. The projects that work on it, the CNI implementation, it's all open source. You can contribute to it. And I think the community have solved that problem of trying to get extensibility, to get the most value out of technology. But I think it really just plays into the same story we're talking about with Wireshark. It's like, we're all here today contributing to a greater good. And I think that's more noticeable in the case of cloud. Otherwise, there'd be far too many shortcomings of these technologies because the cloud providers just said, oh, we thought you were going to move, lift and shift everything to cloud, but they didn't think about how it's going to, again, a multi-cloud strategy.
I really liked that you mentioned Kubernetes here because most people don't realize Kubernetes is recognized as kind of a new technology. At its core, it's 40 years old. Kubernetes is built on the Linux kernel KVM engine, which is a kernel virtual machine, which is pretty much the same thing that runs Docker. And that technique is 40 years old. So it's a nice tie-in to our topic here for talk, because future of Wireshark, yes, there are things coming, there are things, and it's a nice example in comparison, because you have a whole kind of tool set built on top of a technology that's still there, that you can still use to this day. You can still run a KVM engine with nothing more than a few text files. We don't need Kubernetes for that. And Chemo and Chico, the data formats that are running the systems, they're actually open source for the better parts. I think it's 25 to 30 years, something like that. So I think that ties in nicely. I want to say once again, thank you very much for joining us this morning on our panel. It was very, very cool to have you all on stage. Thank you for agreeing to do this. And yeah, with that, we conclude our panel discussion.